These posts claim that the James Webb Space Telescope, JWST, has detected a massive object about 10 light-years away heading toward Earth. Now, when events occur that seem too improbable to be coincidental, we often wonder if they're truly just chance. Think of it like a pool game. Balls are arranged tightly in a triangle, and the player takes a shot. After the cue ball strikes, the balls scatter across the table. But in this scenario, something remarkable happens. One by one, they all travel into the same corner pocket. What would you make of it? A lucky fluke, a sign of extraordinary skill, or maybe something more unusual, like the table being slightly tilted? In the universe, certain occurrences seem so unlikely that they challenge our understanding of probability. Consider the idea of a colossal object careening toward our solar system. It could cause the gravitational disruption of a planet's orbit, potentially hurling it into the depths of interstellar space. Imagine it doesn't stop there. It then ejects another planet, and the two somehow synchronize perfectly, forming an orbital dance as they drift into the void. It sounds almost impossible, right? And yet, in the vast cosmic scheme, improbability doesn't always equate to impossibility. The James Webb Space Telescope has made an extraordinary discovery in the Orion Nebula, within the vast expanse where stars are born. It found something unexpected: 2 rogue planets locked in a binary orbit. Both planets are comparable in size to Jupiter, earning them the moniker jumbo planets. But here's where it gets even more mind-boggling. JWST didn't just find one pair, it discovered 40 such pairs, making up nearly 10% of all the free-floating planets detected in the nebula. These findings don't just defy expectations. They challenge the foundations of our understanding of how the universe works. It's like our cosmic framework is in need of a serious review. The first glimpses of jumbos were captured by JWST in October 2023, thanks to its incredibly powerful instruments, which allowed it to capture high-resolution images of the Orion Nebula. Although jumbos might exist elsewhere in the universe, they've been difficult to spot until now. Their relatively modest size, combined with the complexities of current detection methods like gravitational microlensing, meant they had evaded discovery. Gravitational microlensing involves observing the temporary brightening of a distant star as an object passes in front of it. It's a rare phenomenon predicted by Einstein but once thought to be unobservable. Advances in technology have changed that, but even now, it remains a hit-or-miss method. Only the exquisite sensitivity of JWST has made the detection of jumbos a reality. These newly identified planets are quite young, having formed just 1 million years ago. By comparison, Earth is over 4.5 billion years old. But it's their behavior that baffles astronomers. Unlike other rogue planets that drift aimlessly through space or revolve around distant stars, jumbos orbit each other, separated by about 200 astronomical units, AU, 200 times the distance between Earth and the Sun. This discovery is as fascinating as it is perplexing, forcing scientists to rethink how planets are born and how celestial bodies interact. It appears the universe still has many secrets to reveal, and each new revelation forces us to expand our perspective. Who knows what other astonishing discoveries are still out there? Binary star systems are relatively common in our galaxy. In fact, about 1/3 of all stars in the Milky Way exist in binary or multiple star systems, where 2 or more stars orbit a shared center of gravity. However, as objects get smaller, the likelihood of being in binary systems decreases. For example, 75% of massive stars are in binary pairs, but only 50% of stars similar in size to our Sun have a companion. For smaller stars, the probability drops to just 25%. But for objects smaller than brown dwarfs, those that are not massive enough to sustain hydrogen fusion and are only 15 to 75 times the size of Jupiter, binary systems are practically non-existent. There's no current theory to explain why such objects would form in pairs. And yet, the James Webb Space Telescope has disproven that assumption. When it scanned the Orion Nebula, it detected 540 planetary-mass objects smaller than brown dwarfs. To scientists' astonishment, 9% of these objects were in binary pairs, and 2 even formed a triplet system. This discovery challenges our existing models of planetary and stellar formation, flipping the laws of probability on their head. The high frequency of these Jupiter-mass binary objects, dubbed jumbos, raises serious questions. At 9%, the occurrence rate is too high to be dismissed as a fluke. It forces scientists to reconsider the mechanisms behind planetary formation. There are two primary hypotheses, but neither offers a satisfactory explanation for what JWST has observed. Planetary systems, particularly in their early stages, are chaotic environments. Picture a young Earth surrounded by molten rock, icy comets, and other space debris. Over time, dust clumps together to form rocks, which then merge into asteroids and eventually into fully formed planets. Not everything survives this process, however. Some material is ejected, creating rogue planets that wander alone in the cosmos. Even large planets are vulnerable to this fate. Some scientists believe that our solar system may have once harbored an additional gas giant, only for it to be flung out by the gravitational forces of Jupiter or Saturn. If true, it would showcase the violent and unpredictable nature of planetary systems. This ejection theory could explain the existence of rogue planets, which are believed to number in the billions. But it doesn't explain how jumbos, pairs of rogue planets, form. The odds of two rogue planets being ejected together with matching speed and trajectory, and then capturing each other gravitationally, are astronomically low. The second theory posits that jumbos could form directly in the interstellar medium, just as stars do. In the turbulent environment of a nebula, gas and dust could collapse under gravity to form smaller objects before the mass can ignite nuclear fusion and become a full-fledged star. But there's a catch. This process faces the opacity limit. As a gas cloud collapses, its potential energy is converted to heat. For the object to keep collapsing, it needs to radiate that heat away. But as the object becomes denser, it also becomes more opaque, preventing heat from escaping and creating pressure that resists further collapse. This barrier sets a lower size limit for objects that form in interstellar space, typically no smaller than a brown dwarf. Smaller objects struggle to form at all. In other words, in the absence of an extremely dense environment, or a nearby star, objects like jumbos shouldn't form. The discovery of these binary jumbos challenges both of these theories. Neither planetary ejection nor direct formation in interstellar space fully explains the high occurrence rate of jumbos. The existence of triplet systems further complicates matters. These observations suggest that our understanding of how planetary systems form is incomplete, and that we may be overlooking key factors that drive these processes. The jumbos discovered in the Orion Nebula are forcing scientists to reconsider the very mechanisms that govern the formation of stars and planets. Are these anomalies unique to this particular nebula, or could similar systems exist elsewhere in the universe, hidden from our view? Perhaps the key to understanding jumbos lies in an old theory proposed by astrophysicist Alan P. Boss in 2001. Boss suggested that interstellar magnetic fields could play a crucial role in planet formation. Under certain conditions, his model proposed that magnetic fields might expel a Jupiter-sized object from a collapsing cloud, leaving behind a smaller planetary-mass object. At the time, this idea was speculative, with no observational evidence to support it. However, the discovery of jumbos by JWST offers a striking match to Boss's proposed sizes, raising the possibility that magnetism could be a crucial factor in the formation of these objects. While it's still too early to say for sure, magnetism might be the missing piece of the puzzle. To truly understand these perplexing objects, scientists will need to conduct more observations, refine their simulations, and explore creative new ideas. The discovery of jumbos is just one piece of a much larger puzzle in our quest to understand the cosmos. Each new finding serves as a reminder that the universe is filled with mysteries waiting for us to unlock them.